Target Value Design and Integrated Project Delivery. Target Value Design, TVD, is defined by Darrington et al. 2009 as a collaborative strategy and process for designing based on the articulated project values which become design criteria rather than mere aspirations. TVD's origins lie in manufacturing, and in particular the Japanese automotive industry, ensuring time, cost and quality predictability through lean methodology by adding value, by eliminating waste and maximising effectiveness. The essence of TVD is rooted in lean project delivery philosophy and uses target costing within construction projects in which cost and value, through value management and value engineering, drive the design process. The objective of the TVD process is to design to a target in order to reduce the overall cost of the product over its entire life cycle. This is achieved by working collaboratively and backwards from the client's ultimate requirements of the project and the market cost. This will determine, through detailed estimates, the cost of the project and feasibility before detailed design commences. This slide shows the TVD process clearly showing the process steps and stages which are undertaken ahead of the construction phase to progress the finalised design in line with the client's requirements and their budget. As shown on the TVD process, elements within construction include project definition, design, construction and handover stages. The process begins with a clear understanding of the price the client is willing to pay, which provides the target cost. The project is then defined through client stakeholder consultation in order to determine the functional need of the client, to establish whether the project is feasible in terms of the target cost and the time constraints imposed. As collaborative dialogue continues, then further information comes to light as to the client's functional requirements of the new building, and the design progresses further. During the design process, from the concept stage, all design options remain open until the last responsible moment, with value management and value engineering collaboratively used to determine the best design solutions based upon all relevant design criteria and also disregard those that are not viable. This produces a target cost estimate which validates the client's business plan. Target costs may increase as the design is further developed. If this is the case, then the target must be changed, or further value engineering should take place to ensure the client's budget is maintained. Clifton et al. 2004 suggests that if the target cost cannot be met, then the project should be cancelled rather than continue with an unprofitable project. However, there is always scope to reduce specification and quality in order to value engineer a project to meet the client value needs and maintain the profit margin of the contractor, rather than outright cancelling. It is worth considering the possible large pre-construction costs incurred before considering cancellation. Ultimately, delivery of TVD is achieved through lean tools such as set-based design, choosing by advantages, last planner and plan do check act, and incorporates wider design criteria elements than purely target costing, such as program duration, construction methodology and work sequencing. Whilst TVD has been widely adopted and proved successful within the automotive industry, adoption within the UK construction industry is limited. Nicolini et al. 2000 suggests this is partly because of imposed constraints from the extant procurement and commercial practices, and also from some of the characteristics of the approach itself. Zamini, Ballard and Basquire 2012, in their paper Target Value Design, Collaboration and a Lean Approach to Reduce Construction Cost, undertook action research on 12 construction projects in the USA, and it was shown performance was increased and final project costs were on average 15% less than market cost. The American Institute of Architects defines IPD as a project delivery method that integrates people, systems, business structures and practices into a process that collaboratively harnesses the talents and insights of all participants to reduce waste and optimize efficiency through all phases of design, fabrication and construction. Historically, the industry has been seen as adversarial. Latham 1994, with a culture of blame, command and control, contractual, linear and fragmented practices. However, the IPD approach to the construction industry is a fundamental culture and behavioural change. IPD is an open and relational approach integrating people, processes, practices and structure. Project execution is shown below, demonstrating early resolution of design options during the pre-construction phases in order to maximise efficiency through the construction phase, resulting in a potentially shorter construction phase and ultimately reduce the cost of late changes. This image also shows a paradigm shift moving to building information modelling. The IPD approach promotes the following proactive practices which allow and enable all project participants to contribute to the project's success: learning and continual improvement, target pricing through open book and sharing, paying gain through specific contract types, collaborative and integrated working, knowledge is shared openly, communication is effective and open, designs are progressed and closed out early. Technological tools such as building information modelling provide a collaborative and coordinated design. The essence of IPD is of collaboration between all project participants working towards common goals. In turn, this builds trust among project team members by aligning and maximising their skills in order to deliver benefits to the project and enhance value for the client through the following principles of IPD: mutual respect and trust, mutual benefit and reward, collaborative innovation and decision making, early involvement of key participants, early goal definition, intensified planning, open communication, appropriate technology, organisation and leadership. Collaborative project teams and effective communication are essential to the successful delivery of IPD and are formed at the earliest opportunity within the project. IPD enables integrated and upfront design decisions to be undertaken in the pre-construction phase, which aims to resolve design conflicts and enable shorter construction phase program through collaborative planning workshops involving contractors, suppliers and designers. Contractors are involved earlier in the process and their experience harnessed to provide delivery expertise, cost certainty, phasing and buildability critiques. The AIA IPD guide states that the UK's Office of Government Commerce estimates savings of up to 30% in the cost of construction can be achieved through projects with integrated teams promote continuous improvement across a series of construction projects. BIM is a powerful tool which can be used to aid the implementation of IPD, as it combines a platform for true collaboration between all parties and incorporates both project data and design 3D models from multiple disciplines to provide an integrated and fully coordinated design through a common data environment. This enables construction projects to be front-loaded with the design decisions finalised well ahead of the construction phase. Different file formats exist between software vendors, including proprietary formats, IFC and XML to name a few, but in order for BIM to be more accessible to more users, it requires a cross-platform, web-based solution in order to ensure greater access and enhanced collaboration. Project participants work on their own disciplines model, and then the models are federated within a common data environment such as Autodesk Navisworks to provide a coordinated design. Collaborative benefits of BIM include improved workflow, decision support, optimized solutions, reduced construction phase through developed design, enhanced safety awareness, reduce waste through developed design, whole life cycle asset management. This slide shows Autodesk's integrated project delivery with BIM. This shows the conceptualization, the design, the implementation docs, the construction, and the owner operating stages of the project. Whilst TVD can reduce the likelihood of project cost overruns, alone it cannot remove all cost increases on a project. However, as the TVD approach works backwards from a target cost, this can provide a greater degree of design and cost certainty and reduce the contingency budget of a project. Therefore, TVD must be implemented as part of a wider lean approach in order to drive and manage the project together with enhanced collaboration such as that of IPD. However, clear project definition and front-loading of the project with design information as part of an IPD approach in order to drive target value through client stakeholder engagement is essential to develop the design and ensure a higher level of value delivered and reduced costs incurred through late designs being resolved. Summary and conclusions. Despite similarities, each construction project is unique, not least in terms of differing weathering conditions between projects, changes to project team staff, site ground conditions and many others. This is where construction differs to that of a true manufacturing industry in that often factors cannot be certain. Where a car can be sprayed a different colour, this does not cause delay to the process, where encountering asbestos with an existing building may do so. These factors, coupled with many years of inefficient practices, make culture change within the industry a very slow process. The lack of formal, internationally established IPD standards, and also the lack of specific BIM contract documents, file format interoperability, together with respective legal, security and insurance issues, still to be debated and resolved, also contribute to the lack of progress to fully collaborative working practices in these areas.